Hello, everybody. I'm Mario Linhares, and I'm broadcasting directly from Hilton Phuket, Arcadia. And I've got here one of the stars of SIPS, Sustainable Industrial Processing Summit. I'm here. I have the honor of talking again
Sure.
to Professor Doctor Miguel Angel Alario Franco,
Yes.
who's presented a series of papers in an international symposium named after him and specialized on solid chemistry.
Solid state chemistry.
Solid state chemistry.
That's
Yes.
it, yes.
Well, so it's a great honor talking to you, Professor. It's the second time I interviewed. The first time was online, so
Yes.
speaking face to face, it's always much better.
Yes.
We've had a great opportunity of meeting several times during this past few days, and it's
Sure,
always been
sure.
pleasant. First, oh, don't worry, don't worry. If you want to drink something, feel free.
Yes,
Please.
I never come, but it's just
Yeah. For the ones who don't know, it's very good weather here. Very hot today. Right now, it's 11 o'clock, right?
now it's 11.
Yeah, no, 12:25. It's 12:30.
That's
30
amusing.
past noon. Yeah, 25
I'm
past noon.
nervous because I'm
Yeah.
having an interview. Perhaps I'm nervous.
You're nervous. Oh, no.
No.
Don't worry. We are live. This happens. This happens. Just take your time. Drink your juice.
It's sweet, so it's
Very sweet, yeah, probably.
Yeah.
But then, as I was saying, Professor Miguel Angel
Yes.
Alario Franco,
So
thank you very much
Are
for
we
coming.
live now?
Yeah, we are live.
But then you will cut this part. I mean,
No, we are live. Don't worry. This happens when we are live. We're being broadcasted. If you're watching us on YouTube, on LinkedIn, on Twitter, and
you will see
also
me
on
coughing
Facebook.
and this,
Everybody coughs. Don't worry about that. Come on. But let's start. First, thank you very much for this opportunity again. Yes. And I would like you to state your initial words, your beginning words.
Well, I started doing chemistry when I was in my youth, and I liked it very much, the subject chemistry, and I decided to be a scientist and a professor, because in fact my career has been characterized by these two aspects of the same thing. So I like to create science and to show science to the others, that is teaching. And I have, I got this, and it was a very fortunate decision, because in fact, I loved the job and I loved the activity, and this has allowed me to have a good career in which I have many students, and just teaching. I probably have had about 9,000 students along the year.
Wow.
Which is in university.
How many years teaching?
University students.
Yeah. How many years at university?
Well, I've been in university. I started in 1959, and well, I'm mostly retired now, but I officially retired 10 years ago, but I've been emeritus and honorific. Now I'm emeritus honorific, and I keep going 3 days a week to the university just to chat with the
60
people
years.
and the library and so
A little more than 60 years.
Yes, 60 years about.
Very
yes.
good, very good.
And in these 60 years, I have master students, PhD students. Of my 28 PhD students, 14 are professors, university professors in Spain and abroad. And also the others, except 2, are having research groups. So I actually created, one can say perhaps, a scientific school in solid state chemistry, which at the time when I started, in the late 60s, early 70s, it was not well developed discipline. It was relatively novel. And then I contributed in a modest way, but significant, to develop this as a teaching subject, as a degree, and then, but especially as a research subject. And for this, I have to do material things as well, in the sense that we needed to have good laboratories to make samples. So I set up a high pressure and high temperature laboratory, the first one in Spain, and there is still very few in Europe like this. And then to characterize the materials that we prepare, we set up, I find time and money to set up an electron microscopy center. And that was a period in the 70s where it was most unusual to have electron microscopy and diffraction in chemical laboratories.
Okay.
That was especially for physics. And so at that time, the chemists, we started to do this technique, to use this technique, and that has been a big development, very big. We know much better solids thanks to microscopy, and we can interpret the chemical reactions in solids.
And this, what decade was this? What decade was this?
Well, that was in the late 70s,
Late 70s.
well, early 70s, 74, 75.
And do you think this this was like, can you call it a revolution into solid state
It
chemistry?
was surely a revolution in solid state chemistry.
I see.
It started in the United Kingdom mostly, and well, I learned it with Professor Sir John Thomas, that was in Aberystwyth, within in Wales, and then he moved to Cambridge and continued developing this technique. And it has surely been a revolution, because the fact that you can actually visualize, now we can visualize easily atoms, and then that was been very good for solid state chemistry. Perhaps it's nice to say that why we talk about the chemistry of solids. Chemistry of solids is chemistry, of course.
Yes.
But it's a very simple example. If you put a drop of ink on water, you see that the drop dissolves and water becomes blue a little bit. And then if you put, so that happens at room temperature and no problem. If you put a crystal of sodium chloride and a crystal of sodium carbonate and you put them where nothing happens, you're going to stay hundreds of years, nothing happens. So solids have a speciality that they react at high temperature and a different way. So solids have a specific chemistry. The general laws are the same, but the general chemical laws are always the same. But the way chemistry takes place in the solid state is very different.
I see.
And the other characteristic is that solids have defects. If you have a gas, if you have air, air has no defects. You have oxygen, nitrogen, whatever. But in a solid, there are places in which there is an atom missing or an extra atom. And this is very important in two things: in the properties of the solid, that can be a metal or not, depending on it, and in the reactivity of the solid. So the way to prepare solids has these differences. And then for this, normally we use high temperature to mix solids and make new materials. But then the other good characteristic, the other thing we developed in my group was to use pressure. Pressure. At the same time as you heat, you compress.
I see.
And then you facilitate the atoms react together. That we were not the first to do that, but we did it with great amounts. I mean, we set up a good laboratory with two equipment, and there have been in Madrid several groups that came to work using our facility, because, as I said, even still now, there are not that many high pressure, high temperature laboratories to make solids. Yeah.
Now, when we started here, we realized that you've been 60 years teaching and
60
researching.
Years.
60, yeah. Teaching and researching. What is the secret of this longevity? What kept you so animated, so like proactive about science, about chemistry?
Two factors, perhaps two factors. One is that I love what I do. That I mentioned already. That
I remember you told me that.
If you yesterday on the evening, I mentioned that to the general public so that they know it. I say, well, Confucius said, find a job that you like and you will not have to work. So this is that's one reason. The other reason is that, well, every morning I do swimming. I swim every day since many years ago, and I swim for a while, 60 to 80 minutes a day.
Then, how many that's what?
That's about 2.5 kilometers.
Wow.
On a pool. That's on a swimming pool in a closet pool. I mean, you cannot. If you see if you swim on the sea, you cannot stay so
Yes.
every day, especially because in Madrid there is no sea, so it will be difficult to.
Yeah.
Yeah. So exercising. I'm not a sportman at all. I'm just exercise slowly, and then after that I have my breakfast. I read the newspapers and on the iPad, and then I go to work. So since before retiring, I already did swimming. I've been swimming since 1992,
I see.
every day, and I think this is very good for. The other thing you may know, or if not, it will be good to know. One of my friends was a professor of cardiology in the University Complutense, my university, and he went to the United Kingdom to do a postdoc, and he was in cardiology, specialized in cardiology. And his professor was a famous British cardiologist. In the first lecture, he said, the best thing to have a long life is to well choose the parents, you know.
Yeah,
Which
that
is,
makes sense. So genetics is important.
yes, this is what he meant. But of
Uh-huh.
course, you cannot choose your parents.
Yeah, of course,
But
of course.
still,
Yeah,
that
it's
gives you
a
an idea
figurative
that
speech.
so my father was lived quite a number of years. My mother did died sooner and earlier than so. I didn't have both parents very old, but still, some genetic factors are important. But the way you have to live, the way you use your life is very important.
Motivation, right? Because
Motivation and exercise.
I've noticed it before when I spoke to you or when I interviewed you before. When you speak about your job, your eyes sparkle. Like
Yes,
it's like
yes.
magic for you.
Right,
You're
right.
passionate about it.
Yes, I am absolutely happy because, as I say, I understand new things, and I'm always thinking if I do that, what can happen. So, it kind of not really prediction, but just to see how could things be. And sometimes it works, sometimes it doesn't work, but intuition is an important factor in science too. But one thing is intuition, and the other thing is prediction. One should not predict too much, because Niels Bohr, a very famous physicist, Danish physicist, said, prediction is very difficult to make, especially if it refers to the future.
Exactly, exactly. Now us talk a little bit about the symposium that was named after you. What was your impression about the symposium?
Well, this symposium is outstanding in the sense that, well, it's in a special place, so you cannot do many more things than being in the meeting. And so that is convivial. I mean, you are living with the other scientists and you make new contacts. There are very many people here. It's a big meeting. So I met old friends, of course, and new friends, and you can make easily friends. And then that means that you also have a big panorama of science, not only chemistry, physics, engineering, materials. So if you are really participate of the lectures and well, you cannot attend all the symposia. There are 40, but you can select and the main lectures and so. So it's very good to learn and to meet other people. And when you meet scientists, you normally find collaborations, because perhaps he has a machine you don't, or you have a machine. For example, I can tell them,
But you
well,
lack
you
an
can do high
information.
pressure in my lab, and then I go to you to do neutrons. And so meetings are essential in science. I mean, the time of which somebody was at home with a notebook writing equations,
Yeah.
that's past long ago gone. Now, meeting people is fundamental. And then it's also, as I say, it's in a very good place. I mean, you don't have to find to look for comfort. It's comfortable. So
Yes.
you only have to dedicate to science. There's food, accommodation. So everything is all organized so that you don't have to bother about anything but science and
Exactly.
meeting people. So
Exactly.
in that sense, it's a good example of meetings.
Very good. And I was going to ask you exactly about this because I started with your symposium, but the symposium is part of a greater event.
Yes.
Yes, of a bigger event. You know, that is SIPS, Sustainable Industrial Processing Summit. and it's focused on sustainability through science and technology. Yes. And when we talk about sustainability, yes, chemistry sometimes looks like the bad guy.
Yes.
Yes, because the regular person thinks chemistry pollutes,
Yes.
but he forgets that chemistry
Yeah.
brings us innovation. So, what can you say about what is the role of chemistry in sustainability?
Well, in fact, it's true that for a number of years, I wouldn't say centuries, some part of chemistry was polluting, and people didn't take care of residues. But these are long past. Now there is regulation. I mean, industry, chemical industry doesn't pollute at all. It's the industry that pollutes less because they are conscious of the problem they require. So,
Okay.
accepting that in the past the chemical factories could pollute a lake or things, but now this is
Beautiful.
happily enough this is gone. Now the other thing is that you can use chemistry in a good or in a bad way. I normally put the example of the hammer. You know, a hammer is a useful thing.
Yes.
But if you like to put a nail on that, it's fantastic. But if you like to hit somebody with a hammer, the hammer is bad. The
Yes.
hammer is neither bad nor good. It's the way you use. Well, with chemistry, with science, with medicine, it's the same. If you like to do a bad thing, you will do it, whatever is your activity.
Well,
So chemistry in itself is not bad or good. It's normal.
This is a great thing. This is a great thing to end with. So chemistry is not bad. The use we made of it can be bad or good.
Well, we do many. I mean, almost everything is chemistry. In the clothes, the cars, the petrol, the food. All this requires chemical processes. And the good thing is that chemistry has developed very much. Even at the middle of the 19th century, end of 19th century, then all the 20th century, and now it's one of the well-established sciences, and there is a social activity based on science, on chemistry, which is very fruitful, very productive.
Okay. Thank you very much, and it was an honor.
Very
Congratulations
pleased
for everything.
to see you, and thank you for treating me in such a nice way in this conference. Thank you.
Well, that's it. I'm Linhares from Phuket. See you in a very few moments with another interview. Bye-bye.
Bye-bye. Thank you, my friend.